Alright, so I'm going to work out some problems. These are all typed up for you in your notes, but I wanted to do it out separately so that you can follow the steps. So I want to find the derivative. We have f of x is 2x minus 3. This is the definition of derivative. So I'm going to go through the steps one by one. So first, f of x plus h. I get 2, and where there was an x, that's where we're going to plug in x plus h minus 3. So that gives me 2x plus 2h minus 3. My second step is to put this numerator together. So I have f of x plus h minus the f of x. So 2x plus 2h minus 3 was my f of x plus h. And then I have to subtract the original, which was 2x minus 3. So I'm going to clean that up. So first I just distributed the negative sign, and then 2x minus 2x cancel, minus 3 plus 3 cancel. So that's the second step. Third step is to put all this together without the limit. So I have f of x plus h minus f of x. And then I have to put it over h. So all I had left here was just 2h. So I get 2h over h. And these h's simplify. So that leaves me with just a 2. And then finally, take that limit as h goes to 0 of 2. Well, there is no h here, so it is just 2. So I get y prime is equal to 2. Now that makes sense because this 2x minus 3 is an equation of a line. The slope never changes for a line. It's always just equal to 2. So whenever you have something linear like that, when you take the derivative, you're just going to get the slope back out of it. Alright, and the next problem we have f of x is equal to the square root of x. So I'm going to go back through the 4 steps again. The first step was f of x plus h. So again, where there was an x, we're putting in x plus h. The second step, f of x plus h minus f of x. So f of x plus h is square root of x plus h. And then we subtract the original, which is square root of x. There's nothing else I can do. I can't combine those in any way. Third step. Take what we got in step 2 and divide it by h. And then fourth step, take that limit. So the limit as h goes to 0 of square root of x plus h minus square root of x all over h. So if I do a direct substitution, right, because that's always the first step, I get square root of x minus square root of x is 0 over 0. So I'm in indeterminate form. Well, because I'm in indeterminate form, I want to see which technique I should use. Well, I have radicals here. So if I have radicals, that means I'm going to try the conjugate as my first step. So I have square root of x plus h minus square root of x over h. And I have to multiply that by the conjugate. So this square root of x plus h is going to become plus square root of x. And because I can't change the value of anything, I have to multiply with the exact same thing on the top and the bottom. So when you multiply this out, square root of x plus h times square root of x plus h is just going to give me an x plus h. This would give me a positive square root of x times x plus h, and then a negative square root of x times x plus h, so those cancel. And then square root of x times square root of x is x. So I get minus x. Alright, so now I can see that x minus x is gone, and h over h is just equal to 1. So I'm going to try this again. Limit as h goes to 0 of 1 over square root of x plus h plus the square root of x. Well, when you plug in 0 now, that's fine. I get square root of x plus square root of x. So that simplifies to 1 over 2 square roots of x. So this is my derivative. And I can evaluate it for any number greater than 0. It can't be 0 because I have division by 0 here. But anything greater than 0, I can find the slope of the tangent line. And from the original, our domain was greater than or equal to 0. But once we find the derivative, we know that we can't even take the derivative at 0. It has to be bigger than 0. My next example, I have f of x equals 1 over x. So f of x plus h equals 1 over x plus h. F of x plus h minus f of x is 1 over x plus h minus 1 over x. And then 3, we just take that, what we got in 2, and put it over h. So I get 1 over x plus h minus 1 over x all over h. Okay, so now that I have all that, the next step, the last step here, is to take that limit as h goes to 0. So as h goes to 0, I just get 1 over x minus 1 over x, which is 0. And then on the bottom, I get a 0. So again, I'm back in indeterminate form. Well, because I have this complex, I know I need to clear the fraction. So my LCD is x times x plus h. Okay, so we have to distribute. When you distribute here, the x plus h's cancel, and we're just left with an x. And when you distribute here, the x's cancel, so I'm left with minus. And it's important that we're going to put that in parentheses because we're going to have to distribute that. So minus x plus h. And on the bottom, I just have hx, x plus h. So when I distribute this, x minus x, these are going to cancel. And I'm just going to be left with negative h over hx, x plus h. And then the h's are going to simplify to a 1. So I end up having to take the limit as h goes to 0, negative 1 over x times x plus h, which would give me a negative 1 over x squared. So that is the derivative.